Hello, Peter.
Hi, Kari.
So we have today's a fourth series, and it's my turn to challenge you.
Yes, I am so ready.
Okay, so before we start, I read some comments on your YouTube channel, and somebody asked how comes you have episode 1 and then episode 3. Where is episode 2? So
Yeah.
probably we need to explain to people that we exchange. So it's always a monthly challenge for each individual channel.
Yeah.
We're really looking forward that somebody of us gets 1,000 followers. I have now 931. I don't know what's
Ooh,
your.
650, something like that.
So you are growing even faster than me. So hopefully in a couple of months we can change it to a live format, because as soon as we
Yeah.
have 1,000 followers, we can go on a live format and can do this live. Then both channels will be directly shown in the exchange. We're looking forward to that. If you like our content, subscribe, follow, comment, and participate in our challenges.
Yes.
Good. Peter, today is a very easy topic for you,
Okay.
because last time I have challenged you strongly. This is probably for any person who is working with the technologies and working with the coatings, especially or powder metallurgy, has some understanding or roots in this subject. And now you see the screen, I believe, yeah?
Yes, I
Before
do.
we move inside, uh, I want you to guess today's topic. And for this, I have some,
Mhm.
let's say, starting points. What do you see
Yeah.
on this picture?
A jet plane, a jet motor.
Correct. An aero engine or jet plane engine. So, what do you see on this photo?
A wind turbine.
If we go closer, it's a gearbox of a wind turbine. So we see a
Yeah.
cross section here inside. So
Mhm.
it's a gearbox.
Yeah.
So, what do you see on this photo?
A drilling machine to drill a hole in the ground.
Correct. For example, oil and gas drilling equipment.
Mhm.
What do you see on this photo?
That looks like a cutting tool in a piece of metal.
Correct, with a certain water cooling or liquid cooling inside, so it's machining tools.
Yes.
What do you see on this photo?
A hip implant.
Hip implant. Excellent. Artificial knee joint. And what do you see on this photo?
It's a brake disc or brake pad.
It's a combination of both. You see brake pad and you see on the background brake disc. So, my question, what do you believe all those images have in common?
Where?
Very good. Peter,
Yeah.
it's sometimes not so fun to have quizzes with you. You're too smart and too much in this technology, but you're absolutely right. So today's topic is tribology.
Yeah.
And tribology is an interdisciplinary study of friction, wear, and lubrication of interacting surfaces in a relative motion. But we have three main directions of a tribology. One of them is friction. So tell me, what do you see on this picture? I mean, like, this is I-made picture, but at the end of the day,
Yeah. It's the building of the pyramids. And they are pushing a stone. And they have wheels.
yeah,
That's
it's an
new.
artificial intelligence. Actually, I
It's
asked
new for
to make
me
it
that they
without
have
this.
wheels.
No, they didn't. But at the end of the day, it's a friction image, and the resistance to motion when two surfaces interact is nothing else than a friction. So, what do you see on this one?
It looks a bit strange with these wheels going the wrong way.
But at the end of the day,
Yeah, I don't know. Static friction?
It's not a friction, it's a wear. So wheels probably are worn, they had some damage. I mean, like, artificial intelligence is not perfect so far, but
Something.
this is in images. I try to, to keep the Egyptian
Yeah,
background, and
yeah.
I ask, like, give me a wear image. So they interpreted it as a wear of wheels. And what is
Okay.
wear is a material loss or surface damage due to
Mm,
mechanical action.
yeah.
So, and finally, this is a funny one, but
Yeah, uh, that is then lubrication, but looping the
correct.
wheels directly, that's a
Yeah.
bit strange, but it looks like
Yeah,
oil.
this is strange. But at the end of the day, the point here is we see that all those three words, friction, wear, and lubrication, which is not nothing else than use of fluids
Mm,
or solids or even gases to reduce friction and wear, they are all united, connected
yeah.
to each other. So
Mm.
today's topic is related to them, and I want you to start a history. Can you name me a couple of examples which in antique or in earlier times would you consider as a phenomenon of friction wear or lubrication used?
Early civilization. Uh, you could say the way to grind uh, corn to flour. That's a friction method.
That's very
So
nice.
the old mills with stone that grind it, that was they were using friction.
That's correct.
And
So,
and if you look at those stones, the first ones before they had the windmills, there were holes in them because they were grinding them. They were grinding the corn on one spot, so
yeah.
therefore there were wear. So you typically see a hole, sometimes 10 centimeter deep in a big stone, caused by wear from grinding corn.
So you can imagine how much stones we had that times in our flow
Yeah.
as
Yeah, a lot.
contamination.
A lot, yeah.
Okay, but Peter, I was trying really to search, and what I found, this is the
Yeah.
first ever evidence on a
Yeah.
friction in action.
Mm.
What do you see on this picture? You see
Yeah.
two
Yeah,
bodies which might be wood,
yeah, it's wood
and
against wood, making a fire.
exactly wood against wood making a fire. So it's a really concept of using friction to start a
Mm.
fire,
Yeah.
just by rubbing two bodies against each
Mm.
other.
Yeah.
So one day people
Uh,
became so smart and used their brains to
mm.
progress in the technology.
Yeah. I
Another
got it.
example,
I
yeah,
got it. I have a disclaimer.
yeah,
Because my name is maybe a little polluted. My father, he died 10 years ago now, but he was an expert in tribology.
hmm,
And I have, when I started in the field of material science, I had people who called me or stopped me at conferences and started to discuss tribology with me.
okay.
And I said, I have no idea. It's not my field. I don't know anything about it. But are you not the son of Per? And I said, yes. But tribology know-how is not transferred in the genes.
So
so
better,
so if somebody listened to this and they knew my father, please remember that the knowledge is not transferred with the genome.
okay. But anyway, so far you are doing very good. What do you
Thank you.
see on the second picture?
That is a wheel.
Correct. Do you have an idea when the wheel was first ever time mentioned in the history of humanity?
I would guess it was 2000 before Christ in Mesopotamia.
Peter, and you're gonna tell me you're not an expert. Yeah, it's more or
I'm
less correct. So I found it was in the Bronze Age, and it was exactly mentioned in Mesopotamia, 2,500 before Christ. And the
Ooh,
final image here, what do you see?
Yeah, I see them pushing a stone on the top of some plates,
Yeah,
and the plates might be there to reduce the friction.
correct. And what you see also here, there is a boy with a water bottle or something similar, and they
Uh-huh.
added water as first ever
Yeah,
lubricant to reduce
lubricant.
friction.
Yeah,
Yeah, so they
smart.
made woods wet and
Mm-hmm.
transferred stones. So
Yeah.
this is how the tribology was ever mentioned.
Mm.
Probably we're going a little bit away to something which you can tell me better than I can do. What do you see on the pictures?
Oh, I don't know what that is.
No? No
No,
idea?
no.
And okay, then I will help you. It's
Yeah.
ball bearings made from wood,
Okay.
and this is was archaeologically found on some lake called Nemi,
Mm-hmm.
and they were used to support rotating platforms. So the first ever
Ah,
bearings
yeah. Okay.
were coming not from powder metallurgy or any other metals; they were just made by wood.
Yeah.
This was a
Technology
surprise
has
for me.
has improved.
You say it. Okay, so this was the history, just more a little bit fun that you see that we interact with friction, wear,
Mm.
and actually lubrications already since many thousands of years. However, the modern tribology was firstly introduced in 20th century. And my questions to you,
Mm.
um, do you have an idea when was it first time officially done? Maybe you even know the name of the person who did it. And then what impact does friction wear or lubrication had on economy? Primarily wear, of course.
Yeah.
Just rough estimations.
Uh, in the 20th century, it must
Yes.
be pretty early, uh, because industry and cars and trains started to wear off some. So I guess in the very beginning, in the 10th.
Yeah, I was also thinking like this.
Mm.
However, the reality was that the first ever time
Whoa.
tribology was mentioned as a science was in 1966 by British
Wow.
engineer Peter Yost. So you have the same name.
Yeah.
And he brought a report. And what was interesting is this report that the impact on economy loss uh, would be around 1.2, 1.4% from a national product, which is a huge value. And
Yeah.
then I found also a second number just
Mm.
for West Germany from 1976, so 10 years, as I say, that the
Yeah.
costs of friction of air causing
Mm.
damages were around 10 billion Deutsche Marks that time
Yeah.
per year.
Hmm.
So
Yeah.
this is just to give you an idea.
I could
I
easily imagine that level. I think the similar number for corrosion is doubled up. So
absolutely.
so so cost of corrosion cost even more than this.
Okay, but let's be very honest, that time the industry was still growing, and nowadays I would
Mm.
assume that the number even might be higher, considering
Yeah.
the production volumes we have. Of course,
Hmm.
we do many things to reduce wear, improve our coatings, and so on. That's what we're going
Mm.
to talk more in details today.
Yeah.
Um, Before we continue, for me, what do you see on this picture? This is actually a very simple explanation of
Yeah.
law of friction.
Yeah. There.
With,
Yeah, I see two different components against each other, where the contact point, the contact surface area, is reduced to very low areas because there's maybe been some corrosion attacks around it.
what you explain is very good.
Mm.
However, this is not necessarily happened by corrosion. So, what is the difference between old time tribology and modern tribology? With modern tribology, we learned how to look in a microscopic scale
Mm.
of matter. That means if you can imagine two bodies, Let's take smartphone, something like my badge, and they rub against each other, causing friction.
Yeah. Then you have some adhesive friction.
Not necessarily. We don't talk about wear. We talk about things that when this body interrupts against this body on a microscopic scale, it's not like you have a flat surface interacting against flat surface. You have always so-called asperities. So it means you have contact points due to the surface roughness which interact with each other. So the law of friction, which was considered in, I think it was 1930s even, yeah, by two brilliant, I would say, engineers and scientists. We have so-called apparent contact area, which would everybody say. If we have two bodies rubbing each other, you have the full surface connection. But the reality is that you have a true contact area, which is only a few points which interact with each other. So what you see here, this is a real interaction areas. And this is a law of friction.
Yeah.
So basically, you can impact friction by changing not only material, but also changing the surface roughness. You can imagine if two parties are much more better polished, you get different effects.
Absolutely.
So, now, Peter, this is probably more close to you. Wear.
Yeah.
Wear is what causing us damage. Do you know some mechanisms of wear?
Yeah. Abrasive wear.
Abrasive wear.
That's my favorite.
Okay.
In my first job doing spray forming, I was making high alloy tool steel that were setting a new standard for abrasive wear resistance.
Okay. So, do you know that there is a differentiation between two-body abrasion and three-body abrasion?
I think, but let me see what that means.
I will tell you in details later. But do you know any other wear mechanisms?
What is it called? Abrasive, and then there's one more. That is called adhesive wear.
Correct. This is a very nice example. So we have adhesive wear, we have abrasive wear. Couple more.
There's some where you also include chemical corrosion.
It's a tribocorrosion, for example.
Tribocorrosion, yeah.
Yeah, but this is not a standard wear mechanism. No. So what do you think about if you take a hammer and hit a surface? What do you cause?
You make deformation.
Correct. It's called impact wear.
Okay.
Then there is also, if you talk about wear, what happens in engines? They ride on a very high rotation speeds, and they have so-called vibration. This vibration is also called a wear mechanism. Called fretting.
Okay. Yeah.
So to help
fretting
you
is also a kind of gluing, isn't it?
To help you.
Yeah.
We have here summarized, or at least I try to summarize you the core wear mechanisms. So you have adhesion, which is not nothing else than when we learned there's asperatives which interact with each other. So if asperatives interact and one material starts to glue or micro-weld to each other and then will be taking out from one surface to another, it's called adhesion.
Yeah.
Second is abrasive, as you mentioned, it's your favorite one. And there's two-body abrasion. That means if we have only two bodies interacting against other, soft against hard and hard against soft, and then the very simple rule, harder material, we're gonna take the softer material away. So cut it away, chip it away, depending on the properties and how hard the opposite material is. There is also so-called free-body abrasion. And what is the difference, Peter, is that you have some media in between.
Yeah. And
So
and
basically,
sometimes that media is even worn out particles from your heart that breaks off, and then they stick in the surface of the soft, uh, and then they can wear the surface of the heart. So the soft part can be like you have a sandpaper. The
yeah,
paper itself does not make any wear on your wood or on your steel. But if you put sand on it as the third party, or if you put hardened particles from the steel in the sandpaper, then it will just increase the wear of the steel.
that's correct. And this is what typically in a real world happens. So two-body abrasion is typically what we have in friction, but in most applications, and the best examples are from many industries where you work in mining industry or oil and gas even, you always have some sand or hard particles in between, which
Yeah.
cause you the most of the damage.
Mm.
So there's another word, another wear mechanism is called fatigue. So where you
Yeah.
do fatigue of the surface and this causes your crack propagation and fracturing. You have erosion, where you have some particles which might be accelerated to surface under different angles, causing deformation or fracturing. And you have fretting, which is caused by vibration. So I have also a description of those classical examples. We already discussed this. We don't have to stay in details, but it's very interesting that independence on which wear mechanisms it caused, different materials behave in a very, let's say, different way. So and this is what makes our life as people who do coatings protection against wear or trying to develop materials have to always find a compromise and try to understand what our customers really have as their issue. If they have erosive wear or fatigue wear, it might not be that you use the same coating.
No, I remember this fatigue wear in rolling mills. When you roll steel or you roll aluminium or plate sheets, you typically want a roll made in very hard material.
Yeah,
But you have this contact point where you every time have a kind of fatigue level, and your highest level of deformation is not on the surface, it's some level below the surface. So you will have these crack propagations going on maybe 2-3 centimeters below the surface.
that's correct.
But if you then have instead of having a full hardened material, if you have a hardened surface and you have a ductile core, then if you can put this crack propagation zone in the ductile, you can avoid this crack propagation.
That's true. That's
So
what
that's
sometimes
pretty
is
smart.
even used as a method how you can stop crab propagation. And let's be very honest, we quite commonly work with two different coatings. We apply some called soft layer, which gives you, for example, we call it buffer, exactly something ductile. And on top, we apply something very hard, which anyway might have already cracks inside due to residual stresses or and also typical cold cracks. And then you don't care about those cracks as long as you don't have, for example, impact or high erosive wear under, let's say, a straight angle. And that's a difference. So we move. Peter, another question to you. So now we go a little bit to physics. What is a coefficient of friction?
It is the relation between the force you have put on the material to make it slide compared to the force you put on top of it.
It's a very good explanation.
Mhm.
With a
Oh.
simple explanation, it is a resistance to motion between two conducting surfaces. So if you have a high friction coefficient, then your two surfaces will need much more force to be sliding, rubbing against each other. And then
Exactly.
opposite, you have low friction coefficient. You can have a very nice sliding with almost no wear.
Yeah.
Can you name me a couple of examples from slow or low and high friction coefficients?
Yes. We use ourselves tungsten-based hard metal against silicon carbide,
Mm-hmm.
lubricated with water.
Mm-hmm.
Has a very low friction coefficient.
Thanks to lubrication
Yes.
at the same time.
Mm.
I was not thinking about the scientific approach because we probably have people who watch us who have no idea what we talk about. So I gave this type of examples from a normal life.
Yeah.
Maybe you can help me and tell me if it's a low or high friction coefficient we see on the pictures. Let's start from upper left one. What do you see here?
I see a water slide, and here the friction is low.
Correct. So the second one?
Yeah, it's a sledge, and it's the same. It's also low friction.
Yeah. And this is the third one?
Yeah, that's ice skating and pretty low friction, and that's also because when you touch the ice with these, you cut pretty hard, and then you locally melt the ice, so you have in fact liquid water lubricating in between.
Yeah. But this is a standard which probably every human knows.
Hmm.
Examples of where low friction coefficient helps us to get in a sliding phase and enjoy ice skating, sledging, or even water rubber, how's it called, sledging.
Yeah.
So
Yeah.
on downside and opposite, what do you see on the first picture?
A bike. And,
bike?
Yeah, and here friction is between the tires and the road.
Yeah, but if you look deeper on this image, you see that this guy is staying on his bike and his back wheel is in the air. So that means he's braking and braking so strong that the wheel is not
he's
rotating
lifting.
and he's lifting. This is an example of high friction where we have a braking, brake pad, brake disc system.
Yep.
Another example here.
Yeah, sandpaper with high friction against the wood.
Correct. So that means in this case we can modify surface wood by having sandpaper, even causing abrasion or grinding effect. But it's also high friction. And this one, what probably many people know, if they go hiking, you have a special hiking shoes.
Yeah.
It's because they have also special profile of their platform.
Yeah.
And
special
because
materials. The mud is very slippery. So the mud itself gives a low friction, but then you wear some high friction shoes.
Exactly. So let's move forward. What type of methods do you know, Peter, to prevent or minimize wear?
Adding a lubricant in between.
Yeah.
Reduce the forces you put on it. Add a high wear resistant layer. Then there's the chemical way. In a steel, if you add nitrogen is I think it's some electrochemical. It doesn't like to stick. So when you have nitrogen in a steel, it's more like Teflon.
Yeah, okay, so anti-sticking properties, but this is again means you add coating, thin film, or you do surface treatment.
Yep.
Okay, so this is more or less what you said. It's great and actually gives you a very good overview that you know how to prevent wear. So lubrication, that's what we learned today also with used since antique times and Bronze Age. Then what you probably forgotten, it's a material selection. So choosing a proper material with proper properties can help you to minimize wear. Surface treatment. And what else? I was like not surprised, but this is actually also a way. It's a design optimization, which is nowadays actually probably going more and more to be used, like working with ANSYS and other model simulations, how I can change design and properties, save material, and also improve lifetime. And environmental control, which means that you probably sometimes need to think what is an environmental factor and how to prevent it. And that's what you say, corrosion. Corrosion is clearly an environmental factor. You live close to the seaside, I believe, Peter?
Yeah.
Yeah. So your air humidity and amount of chlorines is definitely higher than we have here in Switzerland.
Yeah, sometimes you can have this kind of fog coming in from the ocean.
Yeah,
that's pretty harsh for your steel and for your car.
Exactly. So I know it also.
If you want to buy a used car, I recommend to check if it has been living on the west coast of Denmark. Don't buy it because it has been in the harsh environment from the fog coming in from the ocean.
You know, I have very good memories when I was very young and just got my driving lessons. In winter times in Estonia at that time, we used salts to melt the ice and snow on the streets.
Yeah, they do that here too.
Yeah, still, I think in some European countries it's now regulated. But the point is here, what people forget, that those salts, when they dissolve, they interact with metal of your car. So all the bases of cars coming from, let's say, North countries and Baltic countries have extremely high level of corrosion.
Yeah.
That's a side turn. Very interesting observation. Peter, we're coming to a final stage. We had a very nice discussion. I must say, for somebody who considered to say he's not a fan of tribology, even having some gens, you did a great job. And now, together with our listeners, I would like to ask 5 questions as a quiz. I want you to give me an answer, but I will not give the right answer because I want people to check if somebody was listening carefully and can answer all 5 questions properly. So, Peter, what is the primary focus of tribology? Study of thermal conductivity, study of friction, wear, and lubrication, study of electrical resistance, or study of fluid dynamics?
Should I give the answer, or should we leave it
sure,
to...
please.
Okay, I would go for B.
B, study of friction, wear, and lubrication.
Yes.
Next question. In the context of wear mechanisms, what is adhesive wear? A, wear caused by hard particles embedded in one surface. B, wear due to chemical reaction with the environment. C, wear resulting from transfer of material between contacting surfaces. And D, wear caused by repeating cycling loading.
I would go for the C this time.
C, wear resulting from the transfer of material between contacting surfaces, causing local welding, for example. Very nice. Let's continue. So, Peter, who was this guy who made a term, modern term tribology in 1966? Leonardo da Vinci, Giuliano Amontas, Peter Jost, Charles Augustin de Coulomb.
Yeah, I really like the name of this guy. That's Peter Jost.
Okay. Next question. What role do lubricants primarily play in tribological system? A, increase friction between surfaces. B, reduce wear and friction between surfaces. C, act as an adhesive between surfaces. And D, corrode contacting surfaces.
It is B, reduce wear and friction between surfaces.
Interesting answer. Are you sure?
Pretty sure.
Okay. And the final question for today. In tribology, what does term asperity refer to? A type of lubricant. B, a microscopic high point on a surface. C, a wear particle. D, a surface treatment process.
I don't know, but my guess is B.
B, a microscopic high point on the surface. Peter, I hope you enjoyed it. I also show the literature here, so some pictures were not stolen but taken from internet. So also thank you to all those guys who have so much of information about tribology. And thank you for attention. I will now stop sharing, but I want to ask you, how was it for you, Peter?
It was fine. In fact, I learned something new. I was pretty amazed that that the term tribology was so new. As I told, my father worked in this field, and it seems like he was one of the pioneers, because he was working on that in that period. And I remember a lot of people came visit us in our home because he was working on developing test methods with pen and desk. But I really didn't know that it was pioneering job he did.
It's definitely he was. I know that the pin on disk especially quite commonly use PVD coatings for testing their properties also, because it helps you to give both informations, abrasive wear, what is the typical wear there, and also your friction coefficient determination. And for me, I remember, because the university where I was studying at Tallinn and Tallinn University of Technology, there was a very strong group on tribology, and we had also a couple of pioneers coming back from Soviet time, and they were first even wrote the books. My professor, Preet Kulu, was actually a developer of so-called erosion wear testing rigs and under different angles. And I, as a student, was using and taking a lot of these sand bags, really heavy sandbags, bringing them somewhere in basement in a lab and trying to do those tests, and then analyzing different hard metal materials on their behavior under different or various impact conditions of erosion. So for me, tribology was very, let's say, student memory.
It was your weightlifting.
Exactly. Yeah, that's why I still have some muscles. Yeah. No, but honestly saying, I was also surprised that it's coming only from mid of 20th century. Well, it was used before. Also, Leonardo da Vinci, as mentioned name, had some ideas in the interactions, but nobody was taking care of it scientifically. But let's be very honest, the coating exists more than that time. So there were already coatings used to improve certain properties, increase wear resistance, and so on. Just it's a different perspective.
Yeah. And then in my daily job at Syntex, I am also working on a product called friction shims. That works in static condition. So if you have a bolted connection, that is, it could be a gearbox where you have high torque level. Then you have flanges, and if the friction coefficient, the flange against flange, is not high enough to secure that the flange doesn't break off when you have torsion on it, then you can add a shim in between with very high roughness or with hard particles that bite into the surface. So when you bolt it together, you can increase the static coefficient of friction from standard steel against steel, that's 0.15. But adding a shim, you can increase it to with a factor of 5 to 0.8. And by doing that, you are in big machines, you are able to reduce the size of these flanges. And when we talk wind turbines, that reduction can be several hundred kilos.
Wow.
Or it can do that you can transfer 5 times the torque level. So that means that with the same design that you can run a 2 megawatt turbine, you can use the same size, the same dimension, the same geometry to run a 10 megawatt size. So that is in these games, it is a game changer.
It is. It is. And so that's why for me, tribology as a science really can help us to have a systematic approach how we can improve so many various fields in terms of understanding it's like how mechanisms behave. And that's why for me probably the difference between so-called antique tribology and modern tribology was also so you can really realize what's happening on microscopic scale, because on microscopic scale you can explain the mechanisms like asperities interaction, what really happens, what happens on atomic level. And if you have this fundamental understanding, it helps you to put the laws and, let's say, transfer to an industry scale. Welcome. I'm very looking forward for your next challenge. I hope that people were listening to us and leave their comments, and please do the quiz. Try to find answers. I'm very curious if somebody would say, I got 5 out of 5. I will share the right answers if that's required. But I believe, let's say, Peter did a good job.
Yeah, thank you. If I could just give a short, what's that called, introduction to the next quiz.
Sure, go on.
In the next quiz where I will host and I'll challenge you, it will be on a material that has been abandoned for many years, but it seems to have a future revival coming back.
Okay. It sounds already very, very challenging.
It will be a wow experience. When preparing for it, I have been reading fantastic stories, and I was wondering, why do they do that? And now I understand why they do it.
I'm very excited to learn with you.